Hello everyone, I'm Dhara Kansara. I will discuss Universal Shift Register in this video and I will cover the following contents: Universal Shift Register and applications of shift registers. So we have already discussed what is a shift registers. Shift registers simply shift the data. We have already discussed the types of registers that are serial in, parallel out, serial in, serial out, parallel in, parallel out, and serial in, parallel out. So for that all operations we are using different circuits. But suppose in one circuit only I want to shift the data either right side or left side. Okay, so I will use bidirectional shift registers. But suppose I want to shift data right side or left side, and also I want to transmit data serially and I want to receive data in parallel mode, or I want to transfer data in parallel mode and I want to receive the data in serial mode. So all these configurations we can use in this universal shift register. I mean, in one circuit, all these functions can perform. So this is known as universal shift register. So now we'll see what is the universal shift register. We can use one circuit as a CPO, PPO, PSO, or PPO. Okay, so in this is the circuit of universal shift register. In this register, we are using 4 different mux. 4:1 mux. 4:1 mux. 4 D flip-flops. Output of this mux we are applying to D flip-flop. 4:1, that's why 4 inputs, 1 output. 4 inputs are there, that's why 2 control signal, and that are S0, S1. This control signal will be similar, will be given to all these mux, and that are equal. Fine. Now, as I told you, 4 inputs are there. So what is the function of mux? Any one of the input will be passed to the output line, and that depends on this control signal. Suppose this signals inputs 0, 0, then this first line, input line data will be passed to the output line. First line data, input data will be passed to this output line, and this output will be given to D flip-flop. Now, next, suppose I am applying here, the data I am applying here in the second line. So this depends, this control depends on this control signal. LSB is 1 and MSB is 0. So this second line will be selected, and this output will be given to D flip-flop. Now we will see the function of this circuit in detail. Suppose I want to store the data right side. So what I will do, you can see here serial input for shift right. This data I am applying to this second line. Now I want to select this line. That's why I will give LSB is equal to 1. I mean S0 will be 1 and this will be 0. So this line will select, this input line will select, and this input will pass to this output line Y. Now suppose I'm assuming at a time, suppose data is 1. So Y is 1. Y is given to this D flip-flop, so D is 1. If D is 1, you know that Q will be 1. Now this 1 I am applying to the next mux. I mean, we are applying this input to second line of the second mux. So this 1 is shifted here. Okay. As I told you, This control signal are similar. We are applying simultaneously to the mux. So this is again 1, 0. So this line, this input line, data will be passed to this output line. So this one is shifted here. This one I am applying to D flip-flop. So output of this D flip-flop will be 1. Now this one I am applying again to third mux at second line. Then data, again this output will shift here. You can see here I am applying to fourth mux. Now this output I am taking from here. This is what parallel out. And suppose I want this data serially, then we can get this data from here at this output line. Okay, so this is what I'm talking about second mode. So as I told you, this depends on S1, S0 signal, mode control signal. This is 0, then there is no change. Means suppose if I want to store the data as it is in this shift register, then I will give S0 is 0 and S1 is 0. You can see here in this table. No change means I will simply store the data in this shift register. Okay, here you can see 0, 1. So shift right operation will be there. Then so these 4 modes are very important. You must know about this mode. Suppose I am applying 0, 0 here. So what happened? You can see here this data of this mux. Okay, this 0 will be selected and this data, I mean this line, this input line will be selected and will be given to output. This output I am applying to D flip-flop. You can see here. And this output of the flip-flop will be given to again this flip-flop. I mean this mux. Okay. So simply we are storing the data in the flip-flop. So this is what? No change. There is no change in the data. Simply I am using this resistor as a storage element. Fine. Then this operation we have already discussed. Now we'll discuss 1, 0. Means S1 control signal is 1 and S0 is 0. That is what? Shift left operation. You can see here. Suppose I want to shift the data left side in this circuit. Okay. So for that I will give S1 is 1, S0 is 0 to all these mux. Fine. Now this data, I mean the data I want to shift left, right? So this data I will give here to this third line. Number is given 2 because I have started from 0. So I am applying this data to third line of this mux. This input line will be selected and this data either 0 or 1 at a time. So this data will pass to this output line. This output is given to D flip-flop. So either 1 or 0, this I mean to say this data will pass to this output line. And this data you can see here I am shifting to next mux. So you can observe this data shifted to left side, right? So here you can see this data I am applying to this third line again to next mux. Now this data as I am applying 1, 0, so this input line will be selected and this data will pass to this output line. This is given to this flip-flop input D input, then output will be output will be given to the next mux. Okay, third line to this mux. So data is shifting left side. And fourth mode, that is parallel load. Suppose I want to load data parallelly, means suppose I am going to use PIPO or PISO operation, then what I will do, PIPO means PIPO in PIPO or PISO, we must have to load data first simultaneously, then we can shift that data, right? So in this mode, what we'll do, you can see here, we are applying parallel inputs from here and to the fourth line of each and every mux. Means at the same time, means whenever this signals, control signal, mode signal will be 1, 1, then this data line will be selected and this data will pass to this output line. So I am applying here I0, I1, I2, I3 simultaneously, parallel load, right? So I am applying this input signal here. So at the same time, all this data, all this fourth line data will pass to this output line, okay, and given to the flip-flop. So either we can collect this data simultaneously, or if I want to shift the data, then I will use that control mode. Okay, so this is what about universal shift resistor. In this resistor, we are using common circuit, but 4 operations we can perform at a time. Either one of the operation we can perform at a time, and that depends on this control mode signal. Okay, so if it is 0, 0, there is no change. If it is 0, 1, shift right operation will be performed by this circuit. If this control signal is 1, 0, then shift left operation will be performed by this circuit. If it is 1, 1, then parallel load operation will be performed by this circuit. So this circuit I can use for 4 different tasks. But that depends on this control signal. Okay, which control signals I'm going to use? That depends on this application. Fine. So this is what universal shift resistor. Fine. Now we will see applications of this shift resistors. This shift resistors used for data transfer, manipulation, and data storage. As we have already discussed in this video, shift resistors either used to shift the data serially or parallelly, right? CPO, PISO, PPO, different types we have already discussed. So in that types, the shift resistors are used. Okay, this resistor are used in the sequence generator. Then shift resistors are also used as counters, and they are also used as delay circuits. So shift resistors are useful in digital electronics circuit. Okay, friends, thank you.